everyone, this is an introduction to permutation groups. Included in this introduction is identity mapping, inverses, possible permutations, and proper subgroups. So let's get started. So the first one, if you see this is the notation. Here is a mapping. So what it's saying is that 1 maps to 2, then 2 maps to 3, and then 3 maps to 1. So this would be your 1 maps to 2, 2 maps to 3, and then 3 maps to 1. All right. This one right here is called the identity mapping. And if you perform a binary operation on this, it's performed right to left. So for example, and I'm going to use colors. We're going to start right to left. So this one maps to 3, and 3 maps to 1. Hence, we're writing these two numbers. 1, 1. All right. The next one, we're going to do 2 maps to 2. And then go over here, go back to your 2 because that was our last one. 2 maps to 3. Hence, we have 2 maps to 3 because you're just using the first and the last. And finally, 3 maps to 1, and then 1 maps to 2. So we have 3 eventually maps to 2. That's called a binary operation. All right, and the inverse of 1, 2, 3 and 2, 3, 1 is 1, 2, 3, 3, 1, 2. And that's because if you map this, and let's try to do this without writing it down. We'll start with 1. So you're going to write 1. 1 maps to 2. Well, we got to go this way. 1 maps to 3, and 3 maps to 1. So, again, that's 1 maps to 3, 3 maps to 1. So use these two. So 1. And then we're going to go 2 maps to 1. So we start with 2, but 1 maps back to 2. All right, and finally for 3, 3 maps to 2, but 2 maps to 3. Remember reading it left to right, or right to left. So that goes back to 3. 3 goes back to 3. And this is your identity. So that means this is the inverse. Now we can do this again. And we're switching these two. Because the inverse has to work both ways. You have to do A inverse and A inverse times A, or whatever the binary operation is. So let's go here. 1 maps to 2, 2 maps to 1. So we're using the last two. All right. 2 maps to 3, but 3 maps back to 2. And then finally we have 3 maps to 1, and 1 maps back to 3. So that's 3 to 3. So these are the identity permutations, or identity mappings. All right. Now, there are 6 possible permutations of the element. So we're going to let I equal the identity. So that's 1, 2, 3, 1, 2, 3. Then we're going to let A equal, you always put 1, 2, 3 on top, B 1, 3, 2. B, we'll let B put 1, 2, 3 on top, and that's going to be 2, 1, 3. I'm just arranging these in any order. And then let's let C equal 1, 2, 3 and 2, 3, 1. And D equal 1, 2, 3 and then 3, 1, 2. And then we'll let E, whoops, close that up, equal 1, 2, 3 and 3, 2, 1. So there's the 6 possible permutations of this element. All right, they can be arranged in a Cayley table, which I already did here. And for example, let's do D star B. So D star B is A. So that equals A. Or you could write that D was 1, 2, 3, 3, 1, 2. And I'm not going to put the star, but B was 1, 2, 3, and then 2, 3, 1. And A equals 1, 2, 3, 1, 3, 2. So if we want to check that, we can. 1 maps to 2, 2 maps to 1. I didn't write this very good, so this is 3. So that would go from 1 maps to 1. All right, 2 maps to 3, 3 maps to 2. So 2 maps to 3, 3 maps to 2, so this is 2, 3. And 3 maps to 1. I think I wrote this down wrong, so let me write this down again. So, sorry about that. Let me just rewrite this whole thing. So this is 1, 2, 3, 3, 1, 2. Then we had 1, 2, 3, 2, 1, 3. And that should equal A. So let's do this. So 1 maps to 2, 2 maps to 1. So that's 1 goes to 1. All right, second one, 2 maps to 1, 1 maps to 3. So that goes to 3. And then 3 maps to 3, 3 maps to 2. So 3 maps to 2. And this equals your A. This is your A, this is your D, and this is your B. All right. There's also, let's talk about, see if this forms a group. The table is closed because no new elements appear. We have 6 elements, 1, 2, 3, 4, 5, 6. The order is 6. All right, so it's closed. And I is the identity element. Remember, the identity was 1, 2, 3, 1, 2, 3. And that was our I. So that's your identity element. The identity element occurs once in every row and once in every column. So that means every element has an inverse. And associativity is given. All right. Now there are 5 proper subgroups, so let's talk about the subgroups. The subgroups are going to be, let's see, let's put star here. We have I, A, which gives you I, A, and A, I. Another one is, let's squeeze this in here, star, I, B. So this would be IB, IB, and BI. All right, the next one, you're going to get 5 out of these. So we have IC. So, well, actually, IC, we also have ID. So we have the D that goes with this. So for this one's a little different. We have I, C, D, and C, C, D, I. And for D, we have D, I, C. So that's a subgroup. Another subgroup is star IE. So put IE. And that gives you IE and EI. And finally, you have a singular subgroup with just I. So there's 5 subgroups. The order of the groups, this one's 2, 2, 2. This one's 1. And this one's 3. So these are the orders of the elements. And remember, the order of our group here was 6. And the factors of 6 are 3, 2, and 1. And those are the orders of our elements. And that's it. Thank you. Have a nice day. Bye-bye.